Good afternoon. My name is Gigi Richard, and I'm a professor in Physical and Earth and Environmental Science Department here at Colorado Mesa University. And what I'm going to be talking about today is a course, an experimental course that we're teaching for the first time here at CMU called The Future of Food. Now, when you think about the future of food, what comes to mind? Does something like perhaps the Jetsons and their automated kitchen that would spew food for you? That would be a fantasy of mine. Or perhaps Star Trek and a replicator, where you could stand in front of the replicator and say, Earl Grey, hot, and your cup of tea would appear. Or perhaps on this planet, we think about the future of food, and what comes to mind is how is it that we're going to feed a growing population on a warming planet? How is it that when we reach 9 billion people in 2050 with increased temperature and changing in precipitation and more extreme weather events and more people on the planet wanting to eat meat, how is it that we're going to feed all of these people? And that is the question that we're considering in this experimental course. It's a general ed introductory science course that's being piloted at Colorado Mesa University and at Penn State. The course was developed by 4 faculty, including myself and 3 faculty members from Penn State University. The funding for the course development was provided by the National Science Foundation through a center at Carleton College that houses a program about interdisciplinary teaching in geoscience that is directed at solving society's challenges. And so the idea is to have an interdisciplinary course founded in science to help students become more educated about science that will help us solve society's issues. So the course is being piloted here at Colorado Mesa University and at Penn State. The course is hybrid, which means that it's partially taught online and partially in person. And the course is also flipped, which means that the students spend a lot of time outside of class watching videos and reading to prepare to come to class where they actually do hands-on activities and do exercises and group work together in class. The foundation of the course is based on the coupling of the natural system that is necessary to grow our food and the human system that we've developed in order to produce the food to feed our population. The natural system includes the climate, the soils, the water, the topography, and the crops that we grow. And all of those conditions are going to determine which crops we can grow and how that human system develops in order to provide the food. So what sort of irrigation systems do we need to develop? Where are the markets to provide the food? What is the price of the food? Where's the infrastructure to provide the food to the people who are actually going to consume it? That's the human system. And this natural system and this human system are coupled, and they affect and they influence each other. It's very clear how the natural system influences the human system. We, depending on what climate we have. For example, here in the Grand Valley, we have a very dry, fairly warm climate, which allows us, and great soils, and allows us to grow many crops, but we only get 9 inches of rain a year. And so the response in the human system side is we've had to develop this very intensive irrigation system to move water from the Colorado River to our fields to grow the food, the wonderful peaches that we have here in the Grand Valley. The human system also affects the natural system. For example, if we apply too much fertilizer to a farm field, those nutrients may run off and end up in a stream, which then may end up in the Gulf of Mexico, if you're east of the Continental Divide, and contribute to the algal blooms that fuel the dead zone in the Gulf of Mexico. So our human side of the food system also has some pretty significant effects on the natural side of the system. So that's the foundation that the students are getting in the basis of this course. The next piece we have to understand in thinking about the future of food is what are the resources that go into growing our food? It takes a lot of water to grow food, and it takes a lot of energy to grow food, fossil fuels. But most importantly, we have to think about the fact that we actually can grow food without oil. We saw this in the 90s in Cuba after the fall of the Soviet Union. But we cannot grow food without water. There is water embedded in everything you eat. It takes 1,800 gallons of water to produce 1 pound of beef. It takes 130 gallons of water to produce 1 pound of wheat. The coffee you had this morning, the milk you had with your breakfast, the beer and wine you might have at happy hour this evening, everything you eat has water embedded in it, and water is a crucial part of our food system. Globally, all of the water that we use globally, 70% goes to irrigation, to agriculture. In the state of Colorado, more than 80% of the water we use is used for agriculture. So it's clear that water is a key factor. And as the planet warms, and as our weather extremes become more challenging, we have to consider how resilient our food system is to these stressors, or how vulnerable it is. And so this is another piece that the students are considering. What are the characteristics of a food system that can make it resilient to the stressors that we face in the future, to the increasing temperature and increasing population? Resilience is enhanced by flexibility, adaptability, and agrobiodiversity. The more diversity of crops that you grow, the more resilient your system is. A great example, in Peru, one single farmer may be growing 20 varieties of potatoes in a single field. In many parts of the world, in our agro-industrial system, we've lost some of that diversity. So enhancing that diversity, enhancing flexibility, and enhancing adaptability, we can improve our resilience. The lower the biodiversity, the more vulnerable a system is, and vulnerability can lead to food insecurity. So the students are wrapping up the semester. They've spent the entire semester now considering all of these questions. And in particular, what they've been doing is they've been looking at these questions related to specific food regions. So the students have been assigned to groups, and each group is assigned a region. And through the semester, they've been applying the things that they've learned to each of these regions. So we have a group of students looking at the Junín region of Peru, or the Puno region of Peru. One group is looking at Lancaster County, Pennsylvania, and two other groups are in California, or they're not physically in California, but they're studying California, looking at the Imperial Valley in California and the Sacramento River Valley in California. These different regions have very different characteristics of their natural systems. Their climates are different. The amount of precipitation they receive is different. The topography is different. The soils are different. And so the human systems have adapted very differently to produce food in these different regions. So the students are looking at all of the components of both the natural and the human systems in these capstone regions. And then they're looking at how resilient is the food system in each of those regions. How vulnerable is it? And in particular, how vulnerable is it as temperature changes and as population grows? And then most excitingly, the other piece we've been looking at is what are the solutions? What can we change to make these systems more resilient? So once the students have given their presentations and solved all of the world's problems, which I'm excited about in a couple of weeks, then the faculty, those of us that have developed the course, are going to spend the next year reviewing the course material, revising it, enhancing it, improving it. The entire course will go out for peer review, and when it's completed, it'll be available at a publication quality textbook online, hosted on the Penn State system through the Carleton College system also. So that faculty anywhere can use this data and use this course material to teach their students about the future of food. Thank you.